In this session, I am discussing the chapter Electrochemistry. Electrochemistry deals with the chemical transformation produced by the passage of electricity and the production of electricity by means of chemical transformation. There are two types of cells. One, electrolytic cell. Two, electrochemical cell. And here, the differences between the electrolytic cell and electrochemical cells are given. The following are the characteristics of electrolytic cell. In electrolytic cell, electrical energy is converted to chemical energy. The anode has positive charge and cathode has negative charge. And the redox reaction is not spontaneous. The characteristics of electrochemical cells are: in the cell, the chemical energy is converted to electrical energy. Anode has negative charge and cathode has positive charge. The redox reaction is spontaneous. The example is galvanic cell. So what do you mean by a spontaneous process? It is a process which takes place by itself. Redox reaction. What is meant by redox reaction? It is defined as a chemical reaction in which electrons are transferred between reactants participating in that reaction. Redox reaction consists of oxidation and reduction. So what is meant by oxidation? Oxidation. Oxidation is a process in which there is loss of electron. So when loss of electron is there, the reaction is called oxidation. I will give you different examples. 1. Sodium. Giving Na plus electron. Here I am giving only simple reaction, oxidation. I have taken only the oxidation reaction. Sodium gives Na plus electron. So here an electron is lost by sodium so that Na plus ion is formed. So on the left hand side the charge is 0 and on the right hand side also the charge is 0. So what is the oxidation state of sodium? The oxidation state of sodium is 0. 0. Why? According to the rules of assigning oxidation number, a 0 oxidation number is given to any species in the elementary state. So sodium is in the elementary state. And Na plus is having the oxidation state +1 because it is a monoatomic ion. For monoatomic ion, the oxidation number is the charge on the ion. So positive 1 is the charge on the ion. Next example is Mg giving Mg2 plus 2 electron. Here 2 electrons are lost by magnesium, so that Mg2 plus ion is formed. I am assigning oxidation state here. So 0 is the oxidation state of magnesium and +2 is the oxidation state of magnesium in Mg2 plus. And the third example is Fe2 plus oxidized to Fe3 plus by losing 1 electron. So the oxidation state is +2, oxidation state is +3. And another example is Sn2 plus is oxidized to Sn4 plus, losing 2 electrons. And the oxidation state of Sn in Sn2 plus is +2 and that of Sn4 plus is +4. So what we are seeing here, everywhere we can see that there is an increase in the magnitude of positive charge as a result of oxidation. So that is during oxidation. During oxidation, positive charge increases. Positive charge increases. So what else we can observe here? We can see that there is an increase in oxidation number occurring in every reaction. So oxidation is also defined as a process in which there is an increase in oxidation state. So what is happening during oxidation? That is during oxidation, the oxidation state increases. The process in which there is an increase in oxidation number is called oxidation. Yet another example is the oxidation of Cl minus to Cl. So here the oxidation state increases from -1 to 0. In the example, MnO4 2 minus oxidized to MnO4 minus. We can see that the oxidation state of manganese increases from +6 to +7. So it is an oxidation because there is an increase in oxidation number. At the same time, we can see that there is a decrease in the negative charge. The 2 minus charge is reduced to -1 charge, and in Cl minus from -1 the charge is decreased to 0. So that we can explain like during oxidation there is a decrease in the negative charge. And here I have given the previous examples. That's oxidation of sodium to sodium ion. And I am mentioning sodium as reduced form, RF reduced form. And Na plus is the oxidized form. So how will you differentiate between oxidized form and reduced form? Oxidized form will have more positive charge. So in this example also we can see that the oxidized form is Mg2 plus and the reduced form is Mg. So oxidized form is having more positive charge. And in this example Sn2 plus oxidized to Sn4 plus, the charge is increased from 2 plus to 4 plus. So in general we can say that oxidized form has more positive charge and reduced form has less positive charge. In the example Cl minus giving Cl. Cl minus is the reduced form and Cl is the oxidized form. So we can also mention like oxidized form has less negative charge and reduced form has more negative charge. So this is the reduced form. Reduced form is having more negative charge, that is 2 minus, and the oxidized form is having that less negative charge, that is -1. Reduction. Reduction is the gain of electrons. It is a process in which the electrons are gained, and these are the reactions. And reduction is the reverse of oxidation. So here I have given the examples which were explained previously. Sodium ion is reduced to sodium. So here the oxidation state is decreased from +1 to 0. In the second example, Mg2 plus is reduced to Mg, and we can say that the oxidation state is decreased from +2 to 0. And during the oxidation of Fe3 plus to Fe2 plus, the oxidation state or the oxidation number decreases from +3 to +2. And here also we can see that the oxidation state of Sn4 plus, that is 4 plus to 2 plus, there is a decrease in the oxidation state or oxidation number. Or we can say that during reduction, positive charge decreases. We can see that during reduction, there is a decrease in oxidation number. In these examples also we can see that these are also examples of reduction and the oxidation number decreases in this reaction. So here chlorine is having 0 oxidation state. It is decreased from 0 to -1, and the oxidation state of manganese is decreased from +7 to +6 in this reaction, and we can see that there is an increase in the negative charge during reduction. We can see that during reduction, the negative charge increases. The reduction is the gain of electron. So when electron is added, the negative charge increases. Redox couple. Redox couple is explained as having together the oxidized and reduced form of species. It is represented as oxidized form / reduced form, and the reduced form is followed by the oxidized form. The slash represents the interface. For example, copper dipped in copper sulfate solution. Copper electrode dipped in copper sulfate solution. Copper is the reduced form, and in copper sulfate there is copper ion, Cu2 plus ion, that is the oxidized form. So they are present together. So this redox couple is represented as Cu2 plus / Cu. And here we are having different species, and from the species we are making redox couple. The first one, sodium ion and sodium. Here the oxidized form is sodium ion because the oxidized form is having more positive charge. So oxidized form / reduced form, that is sodium. So Na plus / Na. Fe3 plus and Fe2 plus. The oxidized form is Fe3 plus and reduced form is Fe2 plus. So the redox couple is represented as Fe3 plus / Fe2 plus. Similarly, zinc redox couple is represented as Zn2 plus / Zn. And hydrogen ion and hydrogen gas. So when they form a redox couple, it is represented as H plus / H2, where H plus is the oxidized form and the H2 is the reduced form. Then bromine electrode. So this is represented as Br2 / Br minus. So Br2 is the oxidized form and Br minus is the reduced form. And finally we have Al3 plus and Al. Al3 plus is the oxidized form and Al is the reduced form. Hence the redox couple is represented as Al3 plus / Al. A redox couple is also called half cell.